Good afternoon, my geometry whiz kids. It's your ever fearless teacher, Dr. J, trying to build his YouTube fame with amazing channels on math. I'm sure I'm going to have 5 million followers before you know it. Anyway, as always, I need to tell you what happened this weekend. I was downtown looking for a parking spot, and I thought I found one, but it had a sign on it, and it said this: "This spot for parking is for frogs only. All others will be towed." Someone please explain that to Brandon Williams if you'd be so kind. Gotcha. All right. Guess what, guys? Good news. We are setting aside triangles till the end of the semester. From here on out, we're now moving away from triangles into a figure we have hardly touched on at all to this point, but we will spend virtually the rest of the semester on until the very end, and that is circles. There is a lot to talk about with circles. We need to get comfortable and ready to handle circles, okay? So today we'll start talking about some basics. There's some terms that you must know. I will put together a cheat sheet of circle terms that I want you to have. I'll also post it on Schoology. You will be expected to memorize these basic terms. You will not have these for any quizzes or tests. You need to memorize them. You probably know some of them. Others will be new, but should not be difficult. Okay? So be prepared for that. I also asked you in class earlier this week to please have a compass ready to go. A compass is required to draw circles successfully. I know that Ms. Dela Cruz has some compasses available, but I'm quite confident you all went out and did what you were diligently supposed to do and bought your own. All right? So here we go. This is chapter 10, page 530, chapter 10. I would suggest you open up the book so that you can follow along in case you can't read it. I'm filming this on my own, so there's no opportunity for me to zoom in and out. I've tried to pick what I hope is about the best average distance so you can see mostly what I have up here. But again, have your book available or with your partner at your table so you can see what I'm talking about. Okay? So, introduction. Let's talk about the most basic of things. What is a circle? A circle is the set of all points in a plane that are equidistant from a given point called the center of the circle. So they drew one here. Point P is a point, and then all points around it that are equally distant from it form a circle. Very basic concept. Of course, you can draw this, and you will be drawing it here in a little bit, so please get out a piece of paper and your compass, if you haven't already, to be ready to draw. Yay, art time, right? You would put your point on your paper, put the pointy part of the compass on there. I'm calling it a compass, and I made a mistake, by the way. I just realized it's actually a protractor. Thank you for correcting me. All right. Take your protractor, the pointy end of it, and put that on your point you drew. Then open that protractor up whatever distance you want, and you just, once you open that distance, please do not hold on to that because you'll pull it open and closed. Now, what I typically do when I draw this is I put my fingertip on top of the protractor, hold it on my point, and I just carefully rotate it. It's even easier sometimes if I just hold the point and then spin the paper in a circle around that point, and lightly just draw that as you go. Okay? All right. So, the first circle terms you must know. I'm confident you all have heard almost all of these terms. The first one is the radius. The radius is a segment whose endpoints are the center and any point along the circle edge. That is a radius. It's halfway across the circle. A chord, C-H-O-R-D. Okay? C-H-O-R-D, much like a musical chord. A chord is a segment whose endpoints are on the circle. Okay? Any line across from one edge to the other is called a chord. There is a special chord that you know about called the diameter. It is a chord because it goes from one end of the circle to the other end, crossing through the center point. That is the diameter. Common sense should, and you already should know this, would tell you is the radius is half of the diameter, right? The diameter goes all the way across the circle to the center point. The radius just goes halfway. So the radius is 1/2 of the diameter, or the diameter is 2 times as long as the radius. Please remember that. Your next term, a secant. S-E-C-A-N-T, secant. There's a fun word. You probably don't know that word, and that's fine. A secant is a line that intersects the circle in 2 points. Okay? It is different than a chord because a chord is a segment with 2 ends on either side of the circle. The secant is a line that cuts all the way through the circle. Okay? Through any 2 points. Here's this word tangent. This word for tangent is different than the trigonometry word for tangent. Remember in trig, that you're trying to forget already, tangent was opposite over adjacent. The word tangent here has nothing to do with that. It really describes a different line. Down here it's line A. A tangent is a line in the same plane of that circle that intersects that circle in exactly 1 point. So this blue line comes across and just touches that circle at 1 point. That point is called the point of tangency. So it just touches the side of the circle. For a little bit of English fun for you right now, there's a phrase called going off on a tangent. And I've got some of you students that like to do that. My good friend Nathaniel Theodule, my algebra student, goes off on a tangent all the time. What that means is, when you go off on a tangent, you're not getting your line to the center of what you're talking about. You're going off just outside the edge of it. You've utilized whatever the topic is that you're talking about, represented figuratively by the circle, and you're just barely touching that to head off in some other direction of conversation. I do that pretty regularly in my conversations. It drives my wife crazy. Somebody brings up something. It's kind of like Doug from the movie Up, my favorite cartoon that makes me cry every time. No shocker there. But Doug always goes off on tangents. Squirrel. That's his tangent. Okay? But anyway, back to this. So you have secant, your tangent line, and your point of tangency. A secant is not a tangent, and a tangent is not a secant. A secant goes through 2 points. The tangent only touches it at 1 point. All right, moving down. Identifying special segments and lines of this figure. Tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, secant, or tangent of circle C. I'm going to step to this side. So, A says segment AC. What is it? It's halfway across, touching the center of the circle and the edge. That is best described as a radius. Letter B says segment AB. Notice that segment AB does go through the center of C. You could describe segment AB as a chord, but it is best described as a diameter because it goes through the center. Ray, DE, is best described as a tangent, a line that touches the edge of the circle. And then line AE. Line AE, best described as a secant. It touches 2 points of the circle. Okay? You see at the bottom of this. All right. You should have a piece of paper out now. Please get together in groups, like I've been splitting you. I know I'm not there now to split you in groups. I expect you to split like I split you all up when I'm there. I need one of my honor students with each group, or Colin, you should be with a group, or Samuel Alves can be with a group, but I need to have you guys working together, functioning in collaboration with one another. So, teacher, please pause here for a moment, give them time to get into their groups, get it done. I don't want to come back and find out that you drug your feet in getting set. Let's go. All right, so with your paper in your group. These are easy, won't take you long. We'll have some that'll take a little longer. In example 1, what word best describes AG and segment CB? And then in example 1, name a tangent and a tangent segment. So, teacher, please pause here. Groups, find those answers. Okay, so what word best describes AG, segment AG, and segment CB? Segment AG. AG. That is a chord. A secant is a line. The segment that touches those 2 points is a chord. And then segment CB is a radius. Okay, from center to the edge is a radius. It said name a tangent and a tangent segment. So when they say name a tangent, it means make it a line. So our tangent line best described here is DE, line DE or ED. Some of you may have put DB. That's okay. I'd rather have a DE. I wouldn't count you wrong if you said line DB as long as you said line. And then it says name a segment that's tangent. The best answer for that is segment DE, okay, or segment ED. Great, moving on. Next page. Coplanar circles and common tangents. Okay, this is just more visual interpretation. There's no math involved here. This is just describing and understanding what you can see visually. There will be math, but right now the first part is just about understanding, okay? So, where did I set my marker? The black one, I think it's over here. In a plane, 2 circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. Coplanar points that have a common center are called concentric circles, and we'll see examples of that, all right? So they can intersect in 1 point, 2 points, or no points. So, if you look here, the blue one, 2 points of intersection. These 2 circles interlap, they touch on these 2 spots. 1 point of intersection called tangent circles, and they gave you 2 different examples. One has a circle nested inside the other, where they just touch at this 1 point. The other one has them touching next to each other, and a line drawn at that point for tangency. So these are tangent circles where they touch at 1 point. Over here, 2 examples of no points of intersection. These 2 are just free-floating circles by themselves, little bubbles having fun in life, not touching each other, like most FLA students, appropriately. These have 2 circles, one inside the other, sharing the same center point. They are called concentric circles. These become very important in chemistry, understanding how shells line up to describe molecules and atoms, okay? Concentric circles with a common nucleus. All right. A line or segment that is tangent to 2 coplanar circles is called a common tangent. That's what these are, common tangents, another term you should know. A common internal tangent intersects the segment that joins the centers of the 2 circles. A common external tangent does not intersect the segment that joins the 2 centers. So, this one is a common internal tangent because if I were to draw the circle centers here and connect them, you see that this tangent line goes through that, so that is a common internal tangent. Over here, if I draw the circle centers, here looks like, and about here, and have the line that connects them, that tangent does not cross that segment, so that is a common external tangent. And there's another example that I'm going to show you here in just a second. My eraser. All right, so moving up, some examples. Tell how many common tangents the circles have and draw them. Okay? So we've got A, B, and C. Draw as many common tangents as you can. So the first one, we have two circles that are not touching each other in any way. When they don't touch like this, you can draw 4 common tangent lines. 2 internal and 2 external. The 2 internal basically make an X. And, pardon my freehand drawing, that was terrible, but anyway, you get the idea. And then the 2 external are on the outside. Okay? I grab the worst marker. Oh, there's my good black marker. All right, so you've got the common internal and the common external. Boop, boop. But I have 2 circles that touch. They form a common point of tangency, which I can just draw only one line through. Okay? But they also then have the 2 externals. That looks like a snowman. Hey, it's Olaf falling on his side. Let's draw a little carrot nose. Whee! Do you want to build a snowman? I know, sorry. All right. Lastly, we have these 2 circles that intersect in 2 different points. You cannot draw an internal point of tangency here because they are crossed over, overlapped. You can only draw the 2 externals. Okay? So when they're separated, you can draw 4. When they're touched by a point of tangency, you can draw 3. And when they're overlapping, you can draw 2. Okay? And that's what you see down below. They look much nicer than the ones I drew. There's what they drew. All right? So, at the bottom, it's time for you to work out your own examples. Again on your paper, and again in groups. Don't worry about using the protractor right now, just freehand it for now. Tell how many common tangents the circles have and draw them. State whether the tangents are external or internal tangents. Okay, external or internal tangents. Teacher, pause here, please. Okay. Number 3 looks just like this one up above. You should have drawn 4. 2 internal and 2 external. Just like so. Number 4 has only 1. It is an external tangent line. It should be perpendicular. I didn't draw that exactly right. It should be, as we'll learn here in just a second, it should be a line straight up and down, perpendicular to the radius coming out. 1 point of tangency is external. Number 5, hopefully you got the idea, they're concentric circles. They never touch, and there's no way to draw a line that disconnects. There's 0 common tangents to concentric circles. 0. All right? Good. So, easy peasy, lemon squeezy. Moving on to page 532. Okay? Now we start getting a little bit of math involved. Yay, you knew there would be. Theorem 10.1, the tangent line to circle theorem. I just mentioned this in what we just drew. In a plane, a line that is tangent to the circle is tangent if and only if that line is perpendicular to the radius. This line is only tangent if it is perpendicular. You see the 90-degree angle there, perpendicular to the radius. Please remember that as you might envision what's coming down the pipe very soon, because we have a 90-degree angle. I told you we were done with triangles and I lied. Okay? Not totally, but not as much. But anyway, I can then draw triangles and then you're back with working with right triangles again. Okay? So we are going to build upon it inside the circles. All right. 10.2. The external tangent congruence theorem, very basic, common theorem. If I have this point S here outside the circle, and I draw 2 tangent segments on either side of the circle, those segments are equal. Not lines, these are segments. You draw a segment from S to the point of tangency here, and the point of tangency here, and they are equal. Example, verify a tangent to the circle. Is segment ST tangent to circle P? and they gave you these numbers. If it's tangent, that means that this is 90 degrees. So how do I prove? How do I prove that this segment is tangent? Well, you're basically proving, is this a right triangle? And utilizing your knowledge we just went through, the first thing is, can I do this quickly? Is this any kind of a triple or special triangle? It's not. So forget that idea. Okay? Then the next thing is we use Pythagorean's theorem, and we ask this. Remember, your hypotenuse is the side opposite the 90-degree angle. It's also your longest number. So you're asking this question. Does 12 squared plus 35 squared equal 37 squared? Pythagorean's theorem. Does this squared plus this squared equal this squared? And if the answer is yes, then it's a right angle. And as it happens to be, it is. 12 squared plus 35 squared does equal 37 squared. You can use your calculator to determine that. Okay? So that's verifying a tangent to a circle. Then example 4, finding the radius of a circle. Slightly more complex, but nothing terrible. In the diagram, point B is a point of tangency. Find the radius. So, because it tells you point B is a point of tangency, that means it forms a 90-degree angle here. We have a right triangle. So now we need to use Pythagorean's theorem. A squared plus B squared equals C squared. So A squared, R squared, plus B squared, 80 feet squared, equals 50 plus R, all of it squared. Okay? You're going to your higher level algebra now. Yeehaw! How fun! All right, I'm going to put it back over here. So R squared plus 6,400, that's 80 squared, equals, we got to FOIL that out, 2,500, make sure I'm telling you right, yes, plus 100R plus R squared. And now I just simplify. I'm going to subtract R squared from both sides. I get 6,400 equals 2,500 plus 100R. Subtract 2,500 from both sides. I get 3,900 equals 100R. Divide by 100 on both sides. If you don't know by now, when you divide by 100 a number like this, you just get rid of the two zeros. R equals 39. So your radius of this circle is 39 feet. Kind of fun. I know it's sad that I find that fun. You have to deal with it. Okay? I enjoy this kind of stuff. It's manipulating data to get to an answer. It's actually valuable work for all of you to learn to do, because in whatever you choose to do for your career, you will have to manipulate data. It may not be numerical, but you still have to learn how to manipulate data successfully. So learn it, love it, and live it. Yeah, baby. That's L cubed. All right. I am having way too much fun filming myself doing this. Sad little life. All right. And Miss Dela Cruz just came in. She's in the back in her office, and she's giggling at me. So there you go. All right. I think we're almost done. Let me see. Oh, good. This is where you get to practice how to draw a tangent to a circle using your protractor and a straight edge. They're calling it a compass. Am I wrong the whole time? A protractor. Isn't a protractor what you use with the point? They're calling it a compass. See, I'm not the only one that got that confused. Your book got it confused. That's a protractor. If I'm wrong, I'm wrong. I'm calling it a protractor. Who cares? All right. So given that you have this circle C and point A, construct a line that is tangent to C that passes through A. Use a compass and a straight edge. This is to do it precisely. So, you are going to do this. Get out your piece of paper and your protractor, Go over and get a ruler for a straight edge unless you don't have one. Teacher, go ahead and pause it here. Give them time to get set up. Great. Let's go on and do this. Instructor, I would advise you, this may take them a little time, so if you need to pause in between steps, feel free to do that to make sure they all get caught up. So the first step that you do, draw a circle. So again, on your paper, put a dot. Open up your protractor as wide as you want, as long as it's not wider than the paper, and draw your circle. Then somewhere outside of that, give it a little distance, not a lot, but a little distance. Pick a point anywhere outside the circle and make that point. Okay, do that now. Next, take your straight edge. From the center of your circle to your point, draw a connecting line. Connect a line from the center of your circle, which hopefully you put a dot on where your point was, and draw a line from C to A. Okay? Then, take your protractor. This is what we did. Recall back when we did orthocenter and circumcenter, and I had you practice drawing how to determine mid-segments of a line. It was kind of fun. So here's what you do. Take your protractor, put your point on C, then close your protractor somewhere roughly smaller than the whole segment, but greater than your halfway estimate. Okay? Open it up so it's greater than what your eyeballs estimate as the halfway point, but not as far as the whole segment. And draw a line, a little swish line here, and then swing it down and draw another one down here. Then reverse, put your point of your protractor on A. Do not change that width, the same width that you just used, the other direction, and you'll swing it up and draw your point here and your point here. It's visually drawn right here to what that looks like. So you've made two X's, you put a point where those X's are, take your straight edge and draw a line, and that is the midpoint of that segment. Okay, so now with that midpoint, put your protractor midpoint on that segment. Let me make sure I do this to tell you correctly. Okay. An M with radius MA labeled on the point intersects C as a point. Oh, construct circle M with radius MA. All right, so you take your protractor, put it on your midpoint dot, okay, and then you put it the other end out here at the center of circle C, and you draw another circle. So again, protractor point right here at the midpoint of your segment, open your pencil mark out to the point of C, draw another circle, okay, where where it crosses either one, that's your point of tangency. And so then you take your straight edge from A to that point, or from A to that point, and you've constructed your point of tangency. And again, instructor, you can pause here. Guys, help each other out. I want you to draw it. Spend a little time drawing this. Okay, have a little fun with it. It's not often you can draw for fun and not just do math, okay? I'll pause. All right. Using properties of tangents. Last thing we're going to do. RS, I got to erase. There it is. RS is tangent to circle C at S, and RT is tangent to C at T. Find the value of X. Okay? So, we know that RS is tangent at S and RT is tangent at T. So from this point, both these lines are tangents, and we just talked about the rule for tangency from a point. Both of these are equal. So again, if they're equal, set them equal to each other. Subtract 4, 24 equals 3x, divided by 3, x equals 8. Very straightforward, simple math. All right, last thing to do together on the paper, you'll be turning in at the bottom here, 6, 7, and 8. Instructor, please pause here for this moment for the kids to work together, and we'll come back and solve it and be done. Great. Number 6, is DE tangent to circle C? Is DE tangent to circle C? Okay, so again, we have to use Pythagorean's theorem. Notice here, we know this segment is 2. How big is this segment? Well, it's a radius, so it's got to be 3, because 3 is already given to us as a radius here. So what this means is, this whole length is 5. Is this a point of tangency? In other words, is this a right triangle? I hope you notice right away, this is one of your triples. It's a 3, 4, 5 triple. It is definitely right angle because it's a right triangle triple. DE is a point of tangency. Number 7, ST is a tangent to Q. Find the radius of Q. So, again, we're using Pythagorean's theorem. I have r squared plus 24 squared equals, in brackets, 18 plus r, the whole thing is squared. Now I get my calculator, the thing I hate to do, but I have to do here. So, 24 squared, I think I'd have it memorized, I should, but I don't. R squared plus 576 equals, I'm foiling this out, 324 plus 36r plus r squared. Okay? I'll review FOIL with you for those of you that are forgetting that right now. Okay? But not today. When I get back, I'll review it. So I'm gonna subtract r squared from both sides. That leaves me with 576 equals 324 plus, that's a nice way of writing 324 as 344. Let's try that again. Plus 36r. Subtract 324 from 576. I get 252 equals 36r. Divide by 36, and it's 7. The radius is 7. Lastly, points M and N are points of tangency. Find the value of x. This one's very easy. It's giving you 2 lines that are tangent from the same point, which means they're equal. Set those equal to each other. X squared equals 9. Square root both of them. I have x equals 3. Piece of cake, that last one. The most tricky one is probably the second one. All right? So that's the lesson. I'm going to have given you homework to do over the weekend. Remember, there's no class on Monday. So when we get together Tuesday and Wednesday, we'll go over the homework. I'll give you another worksheet to reinforce this. Our plan will be to quiz on this topic next Friday. Okay? Next Friday. So there you have it. Missed you guys. Looking forward to seeing you next week.